The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome, ladies and gentlemen. I'm DrAvitech, and in this video, we're going to be solving this very problem. Now, if you notice and remember, we've actually done something similar to this. Yeah, but the only thing is the interval was different. So that one, the period was 2 pi. But in this case, the period is 4. The period is 4 in this case. So that's the only difference, but it's still the same. Ideally, when I made that very video, I think you can check it out. Check the thumbnails, because I had to do it in the thumbnails. So check the thumbnails, you're going to see the video. I might link it up here. If I have the time, I might link it up so you watch it, because this function, I'm going to graph it, but might be a little bit speedy with it. So the first part is 1 plus x. The reason I want to graph it is because I have a feeling it's going to be an even function. So we have 1 plus x. So this will become y is equal to 1 plus x. So if y is equal to 1 plus x, what I'm going to do next is to say that I have, let me plot it like this. I want to plot it like this. So this should be my minus 2. This should be 0. And this should be 2. So this is what we have. That's what I have. Next, even though my line is not looking straight. So next, my y-intercept is 1. So the first thing you notice in a function is the y-intercept. So the y-intercept is 1. So we have the y-intercept at 1. Next, since we're saying that the function is 1 plus x from minus 2 to 0, so we're only going to be considering minus 2 to 0. Minus 2 to 0, that's what we're only going to be considering. So when x is minus 2, so we're going to have y equal to 1 plus x. So when x is minus 2, this will be y equal 1 minus 2. So y is minus 1. So y is what? Minus 1. So I'm going to put at s equal to minus 2, we have minus 1. So let me put my minus 1 here. Yeah. So that's what I have. So yeah, so that's the point. Then when x is 0, y is 1 plus 0. So y will now become 1. So when x is 0, so this is 0, y is equal to 1. So I have it here. So these 2 points would connect themselves. That's the meaning. So these 2 points will connect themselves. Let's go on to the next. Let's move on to the next. So for the next one, we have 1 minus x. So y is equal 1 minus x. Now when x is 0 here, this should be y equal 1 minus 0. So y is equal to 1. So which is still the same one that we have here. It's still the same one that we have here. Next, we have y equal 1 minus x. So value of x will now be 2. So this is 1 minus 2. So y will then become minus 1. So this is 2 and this is minus 1. So they will both kind of be here. So these two will then connect. Now as you can see, this is symmetric at the y-axis. If this is symmetric at the y-axis, it is clear that this function is going to be what? An even function. So this function is even because it is symmetric at the y-axis. Alright, so let's proceed. So this is an even function. So I only need to find a naught and a sub n. So a naught is going to be 2 over L integral from 0 to L of f of x dx. So that will be my a naught. Now what is L? L is half the period. Now the period from here to here is 4, because minus 2 plus 4 will give us 2. Or you could say 2 minus minus 2. So that's 2 plus 2, so that's 4. So the period is 4. The period is 4. So L is always half of this very 4. So L is equal to 2. So this will be 2 over 2, integral from 0 to 2. Now what is f of s from 0 to 2? From 0 to 2, f of x is 1 minus x dx. So 2 we cancel out 2. 2 we cancel out 2. So we're going to be left with the integral from 0 to 2 of 1 minus x dx. All right, now let's integrate 1 minus x. If you have to integrate 1, you will get x. If you have to integrate minus x, you will have minus s squared over 2, following the laws of integration. Then you put in your 0 and 2. Then you put in your 0 and 2. So this will become, anywhere you see x, you're going to put 2. So for the first bracket, this will be 2 minus 2 squared over 2. Yup. Then minus, this is giving me 0. Okay. Then put in 0. So this will be 0 minus 0 squared over 2. So that's what I have. So let me take care of this part. Let me wipe this part. So let's proceed. This will become 2 minus 2 squared is 4. So we have 4 over 2. And 4 over 2 is 2. Minus 0 is 0. Minus 0 squared is 0. Now everything here will be 0 because 2 minus 2 is 0. This is also 0. So everything will just be 0. And that's kind of clear. That's kind of clear. You know, when I was previously, earlier on, when I was making videos on this, I don't really find this integral. I just find the area. The area of this part and this part is the same. Area of this part and this part is the same. Then, I don't really think I have the strength, but you kind of get the point. Let's proceed. So a sub n is 2 over L, integral from 0 to L, f of x cos n pi x over L dx. So this is what we have for our a sub n. So this will be 2 over 2 because L is 2, integral from 0 to 2. Now f of x from 0 to 2. F of x from 0 to 2 is 1 minus x. And then we have cos n pi x over L is 2 dx. So this is what we have. Now these two will take care of themselves. So this is what we'll be having left. Now remember that when you have an expression like this, you need to use integration by parts. You have to use integration by parts. So using integration by parts, we're going to write our 1 minus x first. There's a short form for this. So we're going to write 1 minus x first. So that's 1 minus x first. Okay, so I have 1 minus x. Then I'm going to differentiate 1 minus x. If you differentiate 1 minus x, you will get minus 1. That's because when you differentiate 1, you will get 0. Now this minus x here is minus, there's an invisible 1. So when you differentiate this, you just get minus 1. Then next, you're going to be integrating this. You're going to be integrating this. So integrate cosine, you will get sine. I think I should write that with red. So you get sine. So this will be sine n pi x over 2 over, remember that you must always differentiate this bracket. So when you differentiate this bracket, you will get n pi over 2. So n pi over 2, you need to divide by that n pi over 2. That's how you integrate trigonometric function. You must divide by the derivative of the angle. Now this whole thing in red, you need to integrate it again for this part. So for us to integrate it for this part, we're going to have minus, because if you integrate sine, you will get minus cos. Then we have n pi x over 2 divided by, now the angle again has to be differentiated. So when you differentiate this angle n pi x over 2, you will get n pi over 2. It will come and meet this n pi over 2 that has been here before. So now make it n pi over 2 all squared. It's looking bulky. Okay, so this is plus, this is minus, and the interval is from 0 to 2. From 0 to 2. Now, ideally, if you know how this works, you will know that this sign will give us 0. This sign will give us 0. But let me not put the 0 yet, so you see how it becomes 0. So you see why it becomes 0. So this will be 1 minus x sine n pi x over 2 divided by n pi over 2 plus, because minus minus is plus. Oh, sorry. Minus minus is plus. Plus times minus is minus. So this ought to be minus. So this is minus cos n pi x over 2 divided by n pi over 2 all squared from 0 to 2. Now here's why I said this part will always give us 0. This is 2, right? So if you should put 2 here, x, 2 over 2 is 1. 1 times n pi is n pi. Sine n pi is 0. So we've done something like this previously. Sine n pi is 0. Sine 0 is still 0. So even if you put this 0 here, it will still be 0. So this one has to go. It's 0. It's going to be 0. So it's gone. So what's left is just this one. This is the only useful guy that we have. So what I'll do is to say this is equal minus 1 over n pi over 2 squared, then into cos n pi x over 2 from 0 to 2. So what I basically did was this minus, I put it here, so it's minus 1 over this expression, then I put this one separate. So it's still the same at the end of the day. Now anywhere I see x, I'm going to be putting 2. So this is minus 1 over n pi over 2 all squared. Then we have cosine of, if we should put 2 here, 2 over 2 is 1. 1 times n pi is n pi. So this is cos n pi minus cos. Now the next time, anywhere you see x, you're going to be putting 0. So 0 over 2 is 0. 0 times n pi is still 0. Alright, so this is minus 1 over, you can expand this. So since this is all squared, this will be n squared pi squared over 4. Then into cos n pi is minus 1 to the power of n. Then cos 0 is 1. So that's what we have. Now this 4 can come to the top. The 4 can come to the top. So when that happens, this will be minus 4 over n squared pi squared into minus 1 to the power of n minus 1. Now this bracket you see behaves in a funny way, in a particular way. So sometimes it's 0, sometimes we've kind of done something like this before. But let me just do it again. So when n is odd, so this bracket is minus 1 to the power of 1. We're picking an odd value for n. Then minus 1. Minus 1 to the power of 1 is minus 1. And then don't forget there's a minus 1. So this will now be minus 2. So that means this bracket will be minus 2 whenever you pick an odd value. So our a sub n will then become minus 4 over n squared pi squared times this bracket. But this bracket here is minus 2 when it's odd. So a sub n will then become 8 over n squared pi squared. So this is what we have when n is odd. Now when n is even, I feel like there's no need. It's going to be 0. Since I've done this before. We'll give this a try. When n is even, minus 1 squared is 1. 1 minus 1 is 0. So everything will just be 0. So the only useful guy is when this is what? This is odd. Okay, so we have found the useful coefficients that we need. The function is even, so there's no need for you to find b sub n. There's no need. So what I'm going to do is to get the Fourier series. So f of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos n pi x over L. Yeah, that's what I'm going to have. So this is f of x equal to a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos n pi x over 2 because our L is 2. So that's what we have. Now finally, let's put in the numbers that we have. Now a naught over 2, a naught is 0. So this one is gone. This is 0. So this is f of x equal the sum from n equal to 1 to infinity. Now a sub n is this value, 8 over n squared pi squared. Then put in your cos n pi x over 2. Now let's factorize this expression because 8 over n pi is a constant, so you can just bring it out. So this is f of x equal 8 over pi squared. 8 over pi squared is a constant. And then the sum from n equal to 1 to infinity. What will be left to become 1 over n squared cos n pi x over 2. So one thing you need to remember is this is only when n is odd. This is only when n is odd. N is odd. So you do not forget. But like I said, if it's me, and they say, write your answer in terms of n, because this is not the answer in terms of n. And in fact, even if you put odd here, this is not the answer mathematically in terms of odd, in terms of n. This is not the answer. To ensure that you always get odd values, replace your n with 2n minus 1. So be sure that you always get n odd values. Replace your n with 2n minus 1. Let me wipe this part of the board. So let's expand some terms here. F of x is equal 8 over pi squared. Then open up a bracket. So n is odd, right? So let's pick the first odd value. So this will be cos pi x over 2. Now, how did I get pi x over 2? If n is 1, 1 over 1 is still 1. 1 times anything is that same thing. So this is cos, this n here is 1. So this will be 1 times this will still be this. So that's pi x over 2. That was how I got that part. Then plus 1 over 3 squared, because the next odd value will be 3. So 1 over 3 squared cos 3 pi x over 2 plus 1 over 5 squared cos 5 pi x over 2 plus 1 over 7 squared cos 7 pi x over 2. So you see that you will then be noticing that, well, there's a pattern to it. So you do not always need to be looking at this every time. So what if you're asked to put your answer in terms of n? Because this will be the right representation if it's in terms of n. So what you say is f of x is equal 8 over pi squared with the sum from n equal to 1 to infinity. Now, the remaining part of this, anywhere you see n, you'll be putting 2n minus 1. So make that substitution. So this will be 1 over 2n minus 1 squared. And then cos, so this is another n. So that n will become 2n minus 1 pi x all over 2. So this, ladies and gentlemen, will be the answer if they say leave it in terms of n. So this will be the end for this very video. I'll see you in the next one. Bye.